All right, we are rolling. Welcome, Algebra. This is our first video lesson. So this is lesson 1.1, evaluating expressions. We're talking about expressions. So this lesson is going to be a little bit different. We're going to cover a little bit of vocab. I know in math in general, we typically don't cover vocab. And some of the stuff you're probably actually familiar with from Mrs. Rookwright's class or your previous math classes. So some of these terms you're probably going to be familiar with, so you might be able to zoom through this lesson a little bit faster than expected. But we're just going to make sure we know what an expression is, what are the parts of an expression, and then how we can evaluate them today. And that's going to be our short little lesson we have today. So mathematical expression, this is what you're going to want to write down in your math notebook. Expression, that's our vocab word. And then this little definition here. So an expression is a combination of numbers and variables connected with operations such as addition, subtraction, multiplication, division, or exponents. So essentially, an expression is a group or a combination or a connection of different math terms put together, and it's combined by different types of operations. Once again, an operation is any of our little math processes. So addition, subtraction, multiplication, division, exponents, those are all operations. So I have 3 examples of expressions down below. So 3x plus 4, that's an expression. We get a combination of some variables in there, like we said. We have a combination of some numbers, and then we have some operations in there as well. So all those pieces are smashed sort of together in a little one math cluster, and that is our expression. 4 times w minus 3 quantity squared, that's all an expression. We got some operations, we got some numbers, we got some variables. And then a divided by 7 times 4b, that's an expression. Once again, an expression can have any number of numbers, any number of variables, any number of operations, and it doesn't matter. All of that together is our expression. Now we're going to break down these expressions, and we're going to talk about what are some of the different pieces that we have in these expressions. So we got parts of an expression. Our terms that you want to make sure you remember, or the vocab pieces that you want to remember, are all highlighted in blue. And then there's a few red things out there that I'll talk about. So our first little piece of vocab is a variable. What is a variable? A variable is an unknown value represented as a symbol, usually a letter. So you've used variables, I think you start them in 6th or 7th grade. But essentially, a variable is just something that we don't know. It's an unknown term, unknown piece or value that we're trying to figure it out. So typically, you're going to see x. That's your most common variable. Sometimes you might see y, but it can really be any letter or any sort of symbol can represent a variable. So oftentimes mathematicians use Greek letters. So this is the Greek letter theta. This is the Greek letter alpha. So any sort of letter or symbol can come up for a variable. And once again, a variable, it's just an unknown. It could be 7, it could be 18, it could be negative 14. We don't know. We're trying to figure it out typically. So just don't let a variable freak you out. They're just unknown numbers. We're just trying to figure out what it is. A coefficient. A coefficient is a numerical factor that is being multiplied by a variable. So anytime you see a number in front of a variable, that is the coefficient. We talk about coefficients a lot in algebra. It's a word you're going to hear me say a lot. So 4 is a coefficient of this variable. 7 is a coefficient of called a lambda. Is that funny little, I don't know, half of a stick figure. And then 20 right here is our variable for y. Or sorry, not our coefficient for y. So coefficient, once again, and coefficient is always being multiplied by the variable. So this is saying we have 4 x's. We have 7 lambdas. We have 2020 y's. So the coefficient, once again, it's always being multiplied by the variable. It's a factor. It's essentially saying how many variables do you have being added together there for multiplication. Next piece is our term. What is a term? Well, a term is a number, variables and coefficients connected through multiplication. Terms are separated by addition and subtraction. So in our expressions that we had back here, expressions are made up of terms. So terms are always the different pieces that are connected through addition and subtraction. For example, I have Let me use better letter, better color. I have 3x is one term and 4 is another term. So once again, a term can be a number, it can be a variable, or it can be a combination of numbers and variables. So 4x is a term. 6ab squared is a term. 8w is a term, and 9y cubed is also a term. So terms are always separated in order to determine, puns, in order to figure out what is a term and what isn't, or where does one term start and one term end. Look for those additions and subtractions. So 8w is the n, and that is all one term, and 9y to the third is all one term because they're separated by an addition. Constants. Constants are a term that is only a number. So if there's just a number, just a single value or number, that is called a constant term. For example, 9 and 5x plus 9, 2 and 7w minus 2, and 8 and 8 plus 2 theta, those are all constants. And the reason we call them constants is because it's consistent. It's always, 9 is always 9. It's not going to change. So constant values are called constants because they're not changing. They're not doing anything different. It's like that meme of Mr. Incredible from Incredibles 2. Math is math. A constant is going to be constant. It's not going to change. So anytime you see a plain number that's being added or subtracted, that is a constant term. You'll hear that word a lot along with coefficient. And then lastly, we're going to talk about like terms. So like terms are terms that share the same variable. So anytime you have two terms that are being added or subtracted, or it could be 3 terms, 4 terms, 5 terms, it could be any number of terms, but as long as they all have the same variables and the same number of those variables multiplied together, then we can call them like terms. So for example, 5x and 8x are both like terms because they both have a single x in that term. 19y squared and negative 3y squared, sorry, my thing's getting in the way. I can scroll down for you. 19y squared and negative 3y squared are both like terms because they both have a y squared. Now your variables need to have the same exponents as well in order for them to be like terms. If this was just 19y squared and then the second part was 3y and it didn't have that square, they would no longer be like terms. They need to have the same exponents as well. And then lastly, 14ab plus 12ab, as long as they both have the same variables, they're good. So even though we have two variables, a and b are both variables, they're both unknown values, as long as they both have both of those variables, they are like terms. So they both have an ab in them, so they're good. So those are our definitions that we need to make sure we know, are parts of our exponents that we need to make sure we know as we progress through this year. Once again, a lot of this stuff is probably familiar. A lot of these terms you've probably talked about with Mrs. Groupright or in your past math classes. But we want to make sure we have these ready and set to go as we begin this year. So we're going to just do a quick example. We're just going to identify a few parts of an expression. So I have a highlighted blue part of an expression. We need to figure out, okay, what part of our expression is that? So in this first one, 3x plus 9, what is that 9 in this expression? Well, it's a single number with no variables, and it's a single term by itself. So we can call this, we said a single value that's not changing is a constant. So 9 is constant. It's not going to change. I could walk home and I could come back and that 9 is still going to be a 9 because it's constant. 9 equals 9. It's not changing. That's how math works. The second one, we have 4x squared minus 18x. And that 4 is highlighted. So that's that number in front of a variable. So thinking back through our notes that you just took in your math notebook, 4, the number in front of a variable is our coefficient. Make sure I spell this right. Coefficient. Yeah. Should ever still have it. Coefficient. So once again, the coefficient is the number in front of a variable. Anytime we're dealing with a variable and there's a certain number in front of it, that's the coefficient. Now sometimes there might not be a number in front of it. Sometimes you might just see like x. But fun fact, x still has a coefficient in front of it. There's still a number here. It's just an invisible number, and that number is 1. There's only one x. So even if there isn't a coefficient, there typically still is. It's just hidden. It's an invisible little 1. Or sometimes it's even a -1 if it's just negative x. But we'll see examples of that later. 8 minus 5y. What is that whole 5y piece of our expression? Well, it's a variable and it's a number multiplied together, and it's not including the 8 in the negative, or the 8 in the minus there, so this is just by itself a single term. It's one piece of our expression separated by addition and subtraction. In our last example, we have, look at that, 7r to the third s plus 19r to the third s. And we have that 7r to the third s and the 19r to the third s. So what are both these two things? We have two terms because they're separated by that addition sign. So we have one term and a second term. Well, if you look at both these terms, r to the third, they both have r to the third, and they both have an s, so they have the same variables. So this means that they are like terms. Now, once again, a lot of this is probably going to be familiar to you from previous math classes, and that's okay. I just want to make sure we're all on the same page as we jump into our algebra this year. So this stuff's probably easy to start with. Now we're going to talk about evaluating expressions. So we're out of our vocab session, and we're going to jump into a little bit of actual math processes, a little bit of actual doing a little brain work today. So we're evaluating the expression for the given variable. So I have an expression like 4x plus 6, and it tells me that my variable x equals 15. So what is the value of 4x plus 6 when x is equal to 15? So it's telling me the answer to my variable. I just need to figure out what is this whole expression worth if I were to change x to a 15. So all I'm going to do is I'm just replacing x with the number that I know it is, and I'm just simplifying. If I were to replace x with 15, what is this whole value going to be? Well, I'm going to have to, in order to simplify this, I have to think back to my orders of operations. So you may remember from your previous math classes, PEMDAS, or please excuse my dear Aunt Sally. I don't know if they teach you that. They taught me that when I was a little kid. But PEMDAS, parentheses, exponents, multiplication, addition, subtraction. We have to remember that order in order to help us work through this, in order to make sure we get the right answer. So first thing first, parentheses. We do have parentheses. That 15 there is in parentheses, but 15 is already simplified by itself, so we don't have to worry about parentheses. Exponents, we don't have any exponents. Multiplication, we do have a multiplication. Remember, anytime you have a number outside of a parentheses, it's multiplying by whatever's in that parentheses. So 4 times 15, well, we know what 4 times 15 is. 4 times 15 is 60. So this is 60 plus 6. I just did 4 times 15, multiplied that together. Division, we don't have any division. Addition, we do have some addition. 60 plus 6 equals 66. And we are simplified to one number. We don't have any subtraction to worry about. And that is our evaluating expression. So anytime you're evaluating an expression, all you have to do is plug in the value for whatever that variable is given, plug it into the expression, and then simplify. That's all we're doing. And once again, you've probably done this before, so this is probably like super easy, and you're like, Mr. Jarvis, hurry it up. But I just want to make sure we get this down so we can worry about our other things that we have to worry about, like solving equations. All right, so 3a squared minus 8 when a equals 4. 3a squared minus 8 when a equals 4. So once again, we know our value, a equals 4, so we are going to plug that in for my a, my variable. So all I'm doing is I'm just replacing the a with with what I know it's equal to, which is 4. I'm substituting it in, is a term you might hear Mr. Bright use. So looking at our PEMDAS once again, parentheses, once again we still have those parentheses, but 4 is the only number inside those parentheses, so there's nothing to simplify inside. So we're good with inside of my parentheses. Exponents, I do have an exponent this time. I have this square value, so it's 4 squared, or 4 to the second power. Now remember, exponents mean it's like you're multiplying it by itself. So when we have 4 squared, or 4 to the second power, this means we have 4 times 4. So 4 times 4 is 16. So this is 3 times 16 minus 8. Our 4 squared turned into 16. Now, exponents multiplication. I do have multiplication. 3 times 16. 3 times 16 is, Mr. Jervis should know this off the top of his head, but he's drawing a blank at the moment. 48, obviously. So 3 times 16 is 48. And then lastly, minus 8. And we know 48 minus 8, that's pretty easy. That's just a simple 40. So our 3a squared minus 8 when a equals 4 is just simply 40. That is going to be your solution when you evaluate that expression. Once again, we're just simplifying it. We're plugging in a number for the variable and seeing what our answer is when we get there. One more to go. We have, sorry, I hate when this comes up. All right, I'll scroll down a little bit for you as well. I lost my PEMDAS, but that's okay. We know what it is. 5y plus 4y when y equals 8. So this one's a little bit different. Not too much different, but if we notice, we have 2 variables. We have 2 y's showing up in this situation. So when we evaluate our expression, we just have to make sure both of our variables, both of our y's equal 8. Because we know any y that we're given is going to equal 8. So it's going to be 5 times 8 plus 4 times 8. Remember, I know this is multiplication here because I know a coefficient, my number in front of my variable, always is multiplied by that variable. So anytime I replace a value for that variable, I know it's going to be multiplied by my coefficient. So we have parentheses once again, but it's just 8 inside of both of our 2 different types of parentheses. Multiplication, we do some multiplication. We always go left to right when working with multiplication and division. 5 times 8 is 40. I'm going to write this below. 4 times 8 is 32. And then we just have 40 plus 32 is 72. And that is our solution, or our value of our expression when y equals 8. So once again, anytime you are evaluating expression, all you are doing is taking the value you're given for that variable and plugging it in for any of the variables as shown. We're going to do 2 more, and that's where we'll end it for today. 2 more slightly harder questions, but nothing we can't handle because we're all brave, awesome Algebra 1 students. So looking at this first one, 3x squared minus 5x plus 8. So nothing we can't handle, 3x squared minus 5x plus 8 when x equals 2. We just see 2 x's, but just like what we just did in that last problem, I know if there's 2 variables, I have to plug in my value from both of those variables, as long as they're the same variable. So I have 2 x's, so 2 is going to go in from both of those x's. So I'm going to rewrite my problem, except with my value that I'm plugging in. So 3 times 2 squared, because my x was 2, minus 5x, but I know x is 2, so I can replace that with another 2, plus 8. So I just rewrote my problem, and every time I saw an x, I just replaced it with what I know x is equal to, which is 2. So I just substituted in a 2 for every x. Now working through our PEMDAS once again. Now just a quick reminder that multiplication and division go at the same time, and addition and subtraction go at the same time. It's just which one comes first, left or right. So we'll see an example of that in a minute. But parentheses, once again, nothing is happening inside these parentheses. I just use them to help me remember where those exponents are. Exponents, though, or where my variables were. I'm sorry, not exponents. I was getting ahead of myself. Where my variables are. But exponents, we do have an exponent. We have this 2 here. Oh, you gotta be kidding me. So my computer does this fun thing where it gets really slow sometimes, and it slows down, and then it freezes my screen. So I'm gonna take a moment where I'm going to try to fix this really quickly. So hang on just a moment while I wait for my computer to catch up. I will keep talking to you so you're not bored as I grab my charger and seeing if putting a little bit extra charge into my computer helps. Sometimes gets the job done. I hope all of your day is going well. You're probably seeing this on Thursday or Friday. I'm recording this on Wednesday. Not that you care, but I feel like I need to talk some more. Here we go. Let's see if my computer is going to finally get caught up with us. Looks like it's doing a little bit better now. My screen seems caught up, but it seems like my pen isn't working, so give me a brief moment to troubleshoot this. Okay. I think I am back. All right. Sorry about that. That was annoying. All right. So we said we're doing exponents first. So my 2 squared, or 2 to the second power, once again, whenever we see an exponent, it means you're multiplying that number by itself that many times. So it's 2 times itself, because we're squaring it. So 2 times 2 is going to be 4. And I don't need that parentheses anymore, so I'm just going to do 3 times 4 minus 5 times 2 plus 8. Now these parentheses, once again, they're not actually doing anything because there's nothing inside those parentheses that needs simplified. I just like to write them there to help me remember that was where my variable started. But they're not actually doing anything. They're not changing the question anymore. So I don't need to have my parentheses in here from here to here. They're not, this is still the same. Because all the operations are the same. Now we're getting to our multiplication. I got 3 times 4, which is 12. And then 5 times 2, which is 10. So I have 12 minus 10 plus 8. Now, once again, this is where we have to remember that addition and subtraction, even though when we write PEMDAS, we write addition before subtraction, addition and subtraction, just like multiplication and division, happen at the same time. And we really need to focus on whichever one happens first from left to right. So I have 12, and 12 minus 10 comes first before I do 10 plus 8. Because that's important, because if we do 10 plus 8 first, we're going to get the wrong answer. So 12 minus 10 is 2 plus 8, and then 2 plus 8 is 10 as our final solution. So 3x squared minus 5x plus 8 when x equals 2 is 10. We evaluated our expression for x equals 2, and we got the solution of. All right, very last question, almost done. Here we go. We're gonna go with black. Finishing out black. 6x divided by 8y when x equals 4 and y equals 7. What is that solution? Evaluating this expression. Now this is a little different though, because we have 2 variables showing up, but they gave us 2 variables. They told us x equals 4y and y, we actually use 2 colors, equals 7. So when we substitute these in, when we evaluate our expression, we just have to make sure we're paying attention to which variable we're substituting in. Because we got to do it to both. Let's go down a little bit. So whenever I see an x, I'm making sure I'm replacing it with a 4. Whenever I see a y, I'm making sure I'm replacing it with a 7. So this is going to be 6 times x equals 4. So I'm going to replace that with 4. Now this backslash symbol is just divide, showing I'm making a fraction. It's not written top to bottom like we typically do fractions because I can't write it as long as smartboard, but just know that's what it represents. And then h times 7. Because y, anytime you see a y, I'm replacing with 7. So I have 6 times 4 divided by 8 times 7. Now, when we have fractions like this, when we have operations on the top and bottom of the fraction, before we can divide anything, It's best for us to simplify the top of the fraction, best for us to simplify the bottom of the fraction as best we can, and then we'll worry about dividing. So my top of my fraction is 6 times 4. 6 times 4 is just 24. My bottom of my fraction is 8 times 7. 8 times 7 is 56. And here it gets to the fun part. 24 divided by 56. So 24 divided by 56. 56 is definitely much bigger than 24. So this isn't going to simplify to a whole number. We're going to get a fraction as our solution. Fractions as solutions are fine. We deal with those all the time in algebra. So 24 divided by 56. Now, in order for us to simplify this, it's best for us to look at what are some terms that or how can we simplify? What are some common factors of 24 and 56? So what are some numbers that go into both 24 and 56? Well, 24 is divisible by 8. And because this is the same as 8 times 3. 56 is divisible by 8. We just saw that was already 8 times 7. So if these are both divisible by 8, I can essentially factor out or divide both of them by an 8. And that would leave me with just 3 sevenths. So by simplifying my fraction, thank you, we get 3 sevenths. Another way of simplifying a fraction is you could go to a calculator and you could do 24 divided by 56, and then it will, depending on what type of calculator you have, you can hit math, enter, and it will simplify it for you on the calculator. Or if you go to the Desmos calculator, it will automatically simplify the fraction for you. So some calculators do this automatically. Other times we might have to simplify it in our head. But simplifying fractions, don't let that worry you, don't let that freak you out. Fractions are good, fractions are nice. So that's where we're going to end it for today. Once again, I will talk to you either Thursday or Friday when you're probably watching this video. And we'll talk about this, discuss this, practice evaluating expressions a little bit, and we will reconvene again in the following week. So I hope you have a great rest of your day, and I will see you tomorrow or the day after.